So a bunch of stats out there tell us that folks usually swap out their phones every 40 months or so. But lately, that's stretched out a bit. Back in 2020, most people were upgrading their phones every 30 months. Now, if you're one of those gadget gurus who gets a new phone like every other Tuesday, then today's topic might not exactly float your boat. But if you've been rocking the same device for a while, you've probably noticed your battery just ain't what it used to be. Most phones have these built-in batteries, and they're usually lithium-ion, or sometimes lithium-ion polymer. After about 500 to 1,000 charge cycles, their capacity usually drops to around 70% of what it once was. So, after roughly 2 years of use, your phone's full charge just won't last as long. But why does this happen? What's the deal? To crack this mystery, we need to dig into how batteries actually work. Think about your everyday cylindrical battery. It's got a positive and a negative terminal. The positive terminal has higher electrical potential, while the negative one has lower. This difference creates a potential difference between them. And that difference, that's what we call voltage. To help wrap your head around this, let's use a water wheel analogy. Imagine using a pump to lift water up high. Then, that water's gravitational potential energy is used to spin a water wheel as it falls. It's the same deal with electricity. For current to flow, there has to be a potential difference between the positive and negative terminals. This difference, which makes the current flow, is voltage. Your phone's battery also uses complex chemical reactions to create this potential difference internally. This potential difference then forms the voltage, and it works by lithium ions zipping between the positive and negative terminals. Now, the big difference between lithium-ion and lithium-ion polymer batteries is the type of electrolyte, which is basically the path the lithium ions take. Lithium-ion batteries use a liquid electrolyte, while polymer batteries use a gel-like polymer electrolyte. This whole principle is pretty much the same as the world's first battery. You stick a copper plate and a zinc platelet into dilute sulfuric acid. The copper plate with its higher potential is the positive terminal. The zinc plate with lower potential is the negative. Connect them with a wire and boom! Negative charges flow from the zinc to the copper, and current flows from the copper to the zinc. And just like that, the light bulb lights up. But as time goes on, this electrochemical reaction starts spitting out hydrogen ions. These hydrogen ions in the electrolyte, near the copper plate, meet up with the negative charges arriving at the copper plate, and boom, hydrogen gas forms on the surface. During this process, tiny little gas bubbles start to appear and cling to the surface of the positive terminal. This puts a damper on the chemical reaction between the electrode and electrolyte, which in turn slows down the current flow. This phenomenon is called polarization. Using the same idea, when you use your phone, lithium ions move from the negative to the positive terminal, discharging the battery. When you charge it, they zip back from positive to negative. After all that charging and discharging, because of polarization, the ability of lithium ions to return from the positive to the negative terminal gradually drops. So even when your phone says it's full, the actual usable energy slowly dwindles. That's why your battery drains faster. Of course, polarization isn't the only culprit. The active materials inside the battery that participate in electrode reactions can break down. Also, that thin film that forms on the negative electrode surface during the very first charge, called the SEI layer, might not form evenly. All these various chemical changes contribute to your battery's performance dropping over time. Oh, and while we're at it, let's quickly chat about why your phone gets hot when you use it a lot. Electric current is basically free electrons with a negative charge, all flowing in one direction. These electrons are constantly bumping into atoms inside the conductor. During this process, the electrons collide with atoms or ions, creating resistance. This resistance shows up as heat from friction. When you use electronic devices continuously, these collisions just keep piling up, and the temperature gradually climbs. It's a pretty common thing for most electronics. So, was today's little science chat helpful for you?